Greetings everyone. So we'll begin with chapter 1 of intermediate mathematics, which is set, relations and functions. The significance of this chapter, the significant topic is functions. But to know what functions are, you need to understand what relations are. And to understand what relations are, you need to have the basic information about what set is. So let us begin. Set. A set is a well-defined collection of elements or objects that possess same characteristics. You see, the word well-defined is the key word here. Why? Because for an example, you cannot say a set of emotions or a set of habits. Mathematically, they don't have that significance. But a set of natural numbers, a set of integers, rational numbers, irrational numbers, these are well-defined sets. For example, a set of natural numbers like 1, 2, 3, 4, 5, 6 that goes up to aleph naught. Aleph naught, it is the first infinity that you will study in higher classes if you opt for mathematics. So basically, a set of natural numbers, a set of even integers like -4, -2, 0, 2, 4, 2, 4. Alright, so these are very well defined sets. But when we talk about, see, a set of human behavior, can we mathematically say it is a set? No, because characteristics which will be included in this set are not well defined. Human behavior is myriad. Alright. For example, we have a set S that has two elements 1 and 4. We have another set T that has element 3 and 5. So these are two well defined sets. Now let us come to what Cartesian product of sets are. See, S cross T. S cross T means the ordered pairs will be included in a set, and the first element will be taken from S and second element will be taken from T. See, so the Cartesian product of two set S cross T will give us a set that includes ordered pairs. See, S cross T. So first element from S and the second element from T. Okay, so preference will be given to the first element of ordered pair set. Okay, so S cross T is 1, 3, 1, 5, 4, 3, 4, 5. See, S cross T is this set. Now, T cross S, if we have to find, we'll give preference to the elements of T. So how will that be formed? 3, 1, alright, 3, 4, 5, 1, 5, 4. So this is another cross product of the set T and S that goes like T cross S, and the set formed looks like this. Now you see, Cartesian product is not associative. You see, S cross T is not equal to T cross S. In S cross T we have elements like 1, 3, 1, 5, but in T cross S there is no element like 1, 3, 1, 5, no ordered pair like this. So Cartesian product is not associated. This is very important point to be remembered, that Cartesian product of two sets is not associative in nature. Alright, so let us talk about cardinality of these sets. So if you have to find the number of elements that will be present in S cross T or in any Cartesian product set, we have to find the cardinality of individual sets. Like if we have to find the cardinality of S cross T, we'll see how many elements are present in S and then how many elements are present in T. So number of element in S is 2, number of element in T is 2. So the cardinality of this Cartesian product set as a whole is 2 into 2, 4. And if you see vice versa, if you have to find the cardinality of S cross T, you will put the number of elements in T and multiply them by the number of elements in S. That will also give 4. So what do we get here? That the productivity of Cartesian of set is associative in nature, because the means the cardinality of that set in the Cartesian set remains the same, but the two different products of Cartesian set are not associative in nature. So what do we get? S cross T is not equal to T cross S, whereas the cardinality of S cross T and T cross F remain the same as 4. Alright. So we take example of a set A that contains two elements 1 and 4, and we have to find Cartesian product of this A cross A. So how does it go? We have to find the Cartesian product of A with itself. So 1, 4, 1 cross 1, 4, 1. So what do we get as a set? As set as a whole? we get 1 1 1 4 4 1 4 4. So this parent set A cross A is the whole Cartesian product. Okay, so the question arises, why is Cartesian product of this importance? It is because the Cartesian product serves as the parent set for relation. The next topic we'll cover is relations, and this is very important to understand that Cartesian product, all the elements of Cartesian products are the sorry are in one way or the other related to each other. That means when we will read about relations, we'll know that relations come from the Cartesian product set. This set is very important. These kinds of set, A cross A or N cross N, means is a Cartesian product of natural number to natural number, like N cross N, ठीक है, natural number set, or you say integer cross integer, z cross z, or real number cross real number. These are important, very important, because they will serve as a universal set for relations. Okay, so that was all about set and their Cartesian products. Let us move forward to what relations are. See, relation is nothing but a link between two elements of a set. Means there is some kind of recognizable link between various elements of the same sets. See, let us discuss what empty relations are. Empty relations are denoted by phi. It is a Greek alphabet phi, such that suppose R is a relation that belongs to A cross A set and R is empty. So R will be denoted by phi. Phi signifies nullity. Nullity means null element. There is nothing in between. For an example, A is a set of boys. We have a set A that contains boys, and our relation is given that R is a relation in A such that R is equal to A comma B. A comma B is a ordered pair. Always relation set is given by ordered pairs where A is in some or the other way related to B. But first element is related to second element and the relation is presented by an ordered pair. Okay. So R is a relation that contains A into AB such that A is a sister of B. A and B are the element of the set A, right? A is a set of boys. A में सिर्फ लड़के हैं और रिलेशन कहती है कि इस A सेट से ऐसे एलिमेंट्स आ रहे हैं जैसे A is a sister of B. तो क्या ये पॉसिबल है? Is that possible? No. See, A is a set. So suppose it has element A, B, C, D. All are boys because A is a set of boys, and relation is asked that A is a sister of B. This is not possible. So this relation contains no element. It contains no element. Phi. It is an empty relation. Alright. So that was empty relations, and now we'll come to universal relation. The name itself suggests that universal relation means everything, all the ordered pairs are included in the relation. Means if A cross A is the parent set and R relation is derived from A cross A, then all the elements of A cross A are present in R. Means R relation is the proper subset of A cross A. So with a similar example like empty relation, I'll explain this. Suppose A is a set of tigers. Means all the elements in A are tiger. A, B, C, D, all are tiger. And your relation says that A comma B is an ordered pair such that A and B both eat flesh. Tigers are carnivorous, they eat flesh. So in every way, A is tiger, B is tiger, A is related to B, B is related to C, A is related to C, B is related to C. All the elements are related to each other. So what the relation set will be formed? Relation set will be formed like A cross A only. All the Cartesian product set, right? So these kinds of sets are, these kinds of relation are universal relation where complete A cross A is present in relation set. Alright, so we'll move forward to types of relations. So basically there are three types of relations which we will discuss. So let us begin. Let A is a set. I have defined a set that has element 1, 2 and 3. A is the set that has element 1, 2 and 3. R is a relationship on set A. Means R would be some set which contains ordered pair like this, right? So first kind of relation is reflexive relation. Reflexive. What is the literal meaning of the word reflexive? Means something that reflects. And how is reflection is done? The exact image is formed, right? So the very meaning says if if A small a is an element that belongs to the set A, then A comma A is an ordered pair that belongs to relations, right? So suppose for an example, our set A has element 1, 2 and 3. So if our relation has elements like 1 comma 1, 2 comma 2 and 3 comma 3, then R is a reflexive relation, means 1, 2 and 3 were present in the set. So 1, 1, 2, 2, 3, 3 are present in the relation, means if A belongs to the set A, then A comma A should belong to the relation. This is reflexive relation. So what you have to do, you have to check the parent set and see if A comma A type of elements are present in the relation or not. If any of these three is missing, so that will not be a reflexive relationship. Suppose our relation was like this, only 1, 1 and 2, 2 were present. So is this now a relation, reflexive relation? No, because 1, 1 is present, 2, 2 is present, but 3, 3 is not present there. And it is mandatory for every element to have its reflexive property. So this will not be a relation, reflexive relation. But had it been like this, 3 comma 3, then it would be a reflexive relation. So what you have to keep in mind is, if A belongs to a set A, suppose it is very, let us take it as X because A is getting confused. Alright. So if X is an element that belongs to the set A, then X comma X should belong to the relation. Then it will be stated as reflexive relation. Alright. So next kind of relation is symmetric relation. See, what is symmetry? If you put a line of symmetry, then if the image is like this, so another image will be formed like this. Means what? If we see, if it is like 1 comma 2, right? So on the line of symmetry, how does it look? It looks like 2 comma 1, right? This is how symmetry works. So same thing is applied here. See, if A comma B belongs to R, then B comma A must belong to R. Means if ordered pair AB is present in relation R, then BA should also be present in R. Otherwise it will not be a symmetric relation. For example, our set is 1, 2, 3 and we have this as a relation. See, 1, 2 is present, then 2, 1 must also be present there. Let us check. Yes, we have 2, 1 here. If 2, 3 is present, then 3, 2 we should also be present. So this is a symmetric relation. Had it been like this, see, if this element was not there. If this element was not there, then you have 1, 2, you have symmetry of 1, 2 as 2, 1. But you have 3, 2. You also have 3, 2, but you don't have 2, 3 here. So this will not be a symmetric relation, because for this element you don't have the symmetry. Alright, so this is about symmetric relation. Alright, so the third kind of relation is transitive relation. Transitive relations statement goes like, if A comma B belongs to R and B comma C belongs to R, then A comma C ordered pair must belong to R. Means AB belongs, BC belongs, then AC should also belong. AC should also belong to the set R, to the relation set R. For example, we will take the same example as set 1, 2, 3. And we have a relation like this that contains ordered pairs like 1, 2, 2, 3, 1, 3, 3, 1. So you see, 1, 2 is present. If we take one ordered pair AB, we take 1, 2, right? So for 1, 2, we'll check BC. If 1, 2 is there and something starting with 2 is there, yes, 2, 3 is there. If 1, 2, 2, 3 is there, then AC must be present there, right? So what we have to check is 1, 2, 2, 3, then 1, 3. 1, 3 should be there, and you see 1, 3 is also present there. So this is a transitive relation. Alright, in this case, alright, let us see, there is 1, 3, there is 3, 1. Okay, so there should also be 1, 3, 1, 1, right? But 1, 1 is not present. So as a whole, this is not a transitive relation. Why? Because for these two pairs, 1, 2, 2, 3, 1, 3 is present there. So these three make up a transitive relation. But when we check for these two elements, 1, 3, 3, 1, then 1 is not present there. So as a whole, R is not a transitive relation. But Had this not been there, let us remove this. If this was not there, this element, then you see there are only 3 elements in this relation, and you see AB, BC is there, then AC is also there. So this now becomes a transitive relation. So what we have studied, there are 3 kinds of relations: symmetric relation, reflexive relation, and transitive relation. So this is all about relations. Now we will move forward to some examples and questions.